In-rate stuff, there are only a handful of adjustments that you would likely need to make in order to get a successful flight. So the first adjustment is changing the incidence of the front wing. So the incidence basically means changing like the angle of the wing. So like this. If you shift this post down, the wing lowers like that. You see how the wing is lowered? And you can shift it back up, you can shift it back down. So when you shift the back post down, the plane wants to rise, right? Because it catches lift up front. So when you push the back down, it lifts the plane like this in the air. So it will rise. If you put the front post down, like if the front edge of the wing right here is lower than the back side of the wing, the plane will want to go downwards because the air is hitting the plane over here, and it's hitting this first. So if it's hitting this first, it's gonna want to go down. And just show you the other method, the other way again. So if the back is lower, the back edge is lower than the front edge, it's hitting this part of the wing mostly, so it raises it. So it's like pushing this up, raising it like that. Alright, so another adjustment you can do is moving the wing post forward or backwards. So what I mean by the wing post is this piece right here. You can move this piece forward like this. I just moved it forward, and you can move it back like that and stuff. I'll just put that back. So when you move counter to what like you might think, moving it forward does not make the plane dive downwards. Moving the wing post forward all the way to the front of the plane, like this, so moving the wing post all the way to the front of the plane like this, like the front wing, it's going to cause the plane to go stall. So basically, when you put the rubber on and you do the entire when you start the flight, right away, you'll know when the wings are too far forward, when the plane goes like this and starts falling backwards. Or if you see a stall. So a stall is when it goes like up, back, it goes backwards and then it keeps going forward. And then, yeah, it keeps with that motion. So it goes like this, this, this. So if it does stall, that's when you know the wings are too far forward. Or the incidence could be too high. So if the incidence is too high, it could also cause the plane to stall. So let's say the plane, right when you launch a plane, it starts diving downwards. If it's diving downwards, that's when you want to move the wings forward. So you can get it more upwards. So just to recap, if the plane goes up like this, move the wings backwards. If the plane goes down like this, move the wings forwards. Alright, so another aspect that another part of the plane that affects flight behavior is the center of gravity of the plane. So center of gravity is important, like because you don't want the center of gravity to be too far forward or too far backwards, because like if it's too far forward, no matter what adjustments you make over here, well, let me rephrase that. The center of gravity is too far forward, so if it bounces like over here or something, it's more nose heavy. So if it's more nose heavy, the plane's gonna naturally just want to go down, and that's not good, because then if you make adjustments to fix that, they're not going to be efficient adjustments, because the plane's going to be fighting like multiple forces at the same time. Like it wants to go down, but the wings, if you adjust the wings so the incidence is higher, you're trying to fight that force. You're trying to fight that force too much by going upwards. So the ideal center of gravity, in my experience, is right here, like right behind the front post. So maybe like 3/4 inch behind the front post. That should be the ideal center of gravity of the plane. And any adjustments you make sure like revolve around the center of gravity. So let's say you move the wings forward a bunch. Well, maybe you might want to put less clay on the tip if you move the wings forward, because moving the wing forward will increase the move the center of gravity forward. So you might want to reduce the weight on the tip. Likewise, if you move the wings, if you move the front wing all the way backwards over here, you're probably going to want to put a lot of weight on the front. But other aspect that you want to think about when you're doing this is, well, if you move the wings backwards, the plane wants to go downwards. So you don't want to add too much weight. So some things you might see when you move the wings backwards, like all the way back over here. This is like an extreme measure. You're obviously not gonna want to put the wings all the way back here. But if you put the wings all the way back here and you increase the center of, increase the wing incidence a lot, you might be able to get the plane to go upwards. But the problem with this is that the plane will likely travel extremely fast, because it'll be cutting the air extremely quickly, because it naturally wants to go downwards, but you're fighting it with this upward force. So it's trying to go downwards fast. It's going up at the same time. So you'll get like a leveled plane, like it won't rise or fall down, and this isn't good, because first your rubber will unwind quicker because the plane is traveling faster, and you won't get as much height, and it won't be as predictable also. Like you won't be able to predict the height of the plane as easily. And another reason you do not want to let the plane travel extremely quick is because it won't be able to stabilize itself if it hits an object. So when it's flying through the air, it flies around, hits an object. It's harder for the plane to recover if it naturally wants to go downwards. Because when it hits an object, it bounces, then starts diving downwards, and it's harder for the plane to recover since it naturally wants to go downwards. So back to the same point again. You want, in most planes, you want the front wing to be around here. You don't want the front wing to be all the way over here. You don't want the front wing to be over here. You want like a middle distance. So that's how you should start it off. I'm not saying this is like the perfect distance away from the front or the back. I'm just saying that when you start testing your plane, you're gonna want to start testing with the wings in this range, from here to here, somewhere in this range you want to start. So when you start, if you notice it goes downwards, well, move the wings forward. If it goes upwards, move the wing backward. So if you're having another part of the plane is another important behavior is turning. Turning is essential because it's what allows you to not hit the walls when you're testing. It's like you're only given like a certain amount of space, like you're given a gym, so you want to stay within so you don't want to hit the wall, so you want to make circles. By making circles, you're able to stay within the area of the gym. So to make those circles, that's what I'm trying to get to. To make those circles, you can adjust different parts of the wing. So one part you can adjust is the back, right here. So I can't remember exactly what direction the plane goes in when you tilt this, but you're able to, so I'll just show you right now. By moving this piece, you're able to adjust the, change the flight path. So, I don't know exactly, but right now, let's say, hypothetically, I was to offset the back wing like this. So if I was to offset the back wing over here, let's say it goes right, okay? Well, if I wanted the plane to go left, let's say, I would do this. So now it goes the other direction. And actually, I guess you could analyze the way like I would think about the plane. So when I'm thinking about when I'm thinking about turning, so you want to think about how the air hits each part of the plane. So if I wanted this plane to go left, let's say, well, so if I want the plane to go left, I would want if I wanted the plane to go left, you would angle the wings, the back wing like this. The reason for this is that when it goes forward, it's going to be hitting against this edge. So it's, let me get a good view on this. All right, so this is the orientation of it. The front is over there. So if the plane's going forward, it's gonna hit this piece of the wing. No, sorry. It's gonna I think this is a good view. So if you want the plane to turn left, analyze the way the air is hitting the back wing. So the air, when the plane travels forward, is gonna hit right here. It's gonna want to push this like this, because it's not like straight. If it was straight like this, the plane would go straight. But since it's turned like this, the air is gonna hit here. It's gonna push the plane in this direction, making it go left. That's what makes it go in the circles. So if you want to go right, well, how's the air hitting the plane right now? Well, when it goes forward, it's pushing this piece outwards like this, pushing this piece outwards, and it's pushing this piece of the wing outwards also. So it's going to want to go right. You can just look at that. So a quick overview of back wing turning. If you offset the trailing wing to the right, the plane is going to want to go right. If you offset the trailing wing to the left, the plane is going to want to go left. Alright, so that's just one aspect of turning. There's two more. So some years the event only requires that you go in one direction. So both flights only have to be in one direction. So if this is the case, you want to offset the propeller mount. So this piece right here. You want to offset this to, let's say, the left if you want to go left, the right if you want to go right. So you'll probably read this in the instruction packets that you get from like the Freedom Flight models or whatever other model. You can read more into that. Yeah. And another important aspect of turning, so some years and some designs, you're able to tilt this. You're able to tilt this like left, like this or this, and that changes the turning of the plane too. So I'm not really sure exactly I can't remember exactly what direction the plane will turn if you tilt it left or right. But just know that if this edge is lower like this, it's going to turn a certain direction. If this edge is lower, it's going to turn also. And same thing with the front wing. If you angle the front wing down or upwards, it's going to make the plane turn. And lastly, like the last part of turning is wing warp. This is probably the most complex part of the event, because so wing warp is I'll show you what wing warp looks like. All right, so this is the front of the wing. This is leveled. Wing warp is when you twist the wing. So you see how one end is twisted and the other end is not? So wing warp helps turn the plane in a certain direction if you need to go that direction. So this is what I mean. So let's say you're to warp the plane like this. This is a pretty exaggerated warp. You wouldn't warp it this much, but this is just for you, just so you guys can see. So in this example, the left side is lower. So the left back corner, this left back corner is lower than the right side. So when the plane goes forward, it's going to naturally want to go, let's see. Sorry, just give me, I haven't done this in a while. So, a good place to look for wing warp is Scioli.org. If you read the forums from any of the years, but mostly the 2020 year, you'll read a lot of information about how wing warp works. Their forums are probably like 60, 70 pages, but they're extremely helpful. You'll probably learn everything you need to know for the event by reading those, but let's see. Alright, so let's analyze how the air would hit the wing if it was warped in this direction. So if the back wing was lower, it would hit, the back wing was lower like this, it would hit this piece, wanting to, that's what it is, got it. The left side would want to go upwards, because it wants to lift. Since the lower side is higher, since this lower side right here is lower than the front of the side, the left side of this wing right here, this whole piece, this left side, is going to want to go upwards. So when this half of the wing wants to go upwards, well, the plane's going to want to go right. Let me see if I can explain that better. The left side raises, if the left side has more lift than the right side, the plane's going to want to go to the right. Because if you think about it, the plane turns because one side has less lift than the other. So if you want your plane to go right, well, the right side's going to have less lift than the left side. And if you want your plane to go left, the right side's going to have more lift than the left side. That's how you get the plane to turn, basically. And that's what all these adjustments do. They just affect the lift of the plane on each side. So I'll just review that again. If you want the plane to turn right, warp the wing so that the left side gets more lift. If you want the plane to turn right, warp the wing so that the right side gets more lift. And I haven't really changed the warping of the trailing edge. Just change the warping of the front edge if you feel the need to. But most years, so I've done right stuff maybe I think like 3 or 4 years. Like most years, you don't really need to worry much about warping. But if you have a year where they require the plane to go both in the left direction and the right direction on separate flights, well, then that's when you want to worry about warping. So in between flights, you're going to want to change the warp of the wing. So you can make them go left one time, right the other time. But that's not the only adjustment you'd have to make. You'd also have to make adjustment to the tilt on the back, like orientation of the back wing. And yeah. So that's how you turn the plane. So we've gone over what? We've gone over lift. We've gone over turning. I think we've gone over center of gravity. What else is there? That's pretty much all the adjustments you'd ever have to make on the plane. Well, like, you could definitely make more. If you read on the Saoli forums, you could definitely make more adjustments, but these maybe like 4 or 5 main adjustments are the ones you want to prioritize because they're gonna make the most difference, and you're gonna get successful times by just changing these aspects and understanding these aspects and understanding how they work with each other. So I'll just go over different examples right now, and I'm gonna show you why each would work or each wouldn't work. So if we want the plane to turn left, okay? This wing mount is tilted to the left. So it's angled to the left so that the propeller wants to go to the left. So this is a plane already, starting from the front, we know that this plane wants to go left. Well, not that we know this plane wants to go left, but that there's a force going to the left. So now let's go down. Let's analyze the main wing. So when we analyze the main wing, right now there is a slight warp, which makes the right side, so there's a slight warp right now, so that the right side gains more lift than the left side. So if the right side gains more lift than the left side, it's going to want to turn left also. So this is good right now. We have this that wants to turn left, we have this that wants to turn left. And this is good because they're both in the same direction. You don't want the propellers to go left and the wings to want to go to the right. That's not good. Because then you have like counteracting forces that just make everything just less efficient, even if you are able to stabilize it. So now let's analyze the back. And if we analyze the back, the plane is going to want to go left because the air is going to hit the outside of this, make it turn this direction, and it's going to hit the inside of this, make it turn this direction. So it's going to want to go left. So everything on this plane wants to go left. It's not like a drastic left though. It's not like extreme. Each piece slightly wants to go to the left. So if we wanted to make it go right, well, to begin with, this would not be good because you wouldn't want the plane to go to the right with this plane, because the propeller is already set to go to the left. So if your plane goes to the right, well, you have to counteract the force of the propeller that's pushing it to the left. So you have to counteract that by putting more wing warp and by adjusting the back wing more. So to adjust the back wing, as I showed, you tilt it like this. And this would make the plane want to go right. So we just went over, we just analyzed the plane. Okay, you ready? So this sometimes it might seem that everything is working. So like, to begin with, so when you launch the plane, everything's working fine, it's traveling nice and smoothly, and then out of nowhere at the top, so you're going around circles, and at the top it just dives down, makes a sharp inwards dive. So you might have thought everything was fine, but it's not. And usually in this case, the solution is to fix the wing warp. So let's say it dives all to the left. Well, you want to make the wing warp so that you want to change the wing warp so that there's less lift on the right side. So you want to increase the lift on the left side so that it doesn't dive inwards to the left. And let's say this plane went right and it was all the way at the top, and then out of nowhere it just made a sharp inwards dive to the right, like this. Well, then you want to so if it makes a sharp inwards dive to the right, you want to increase the lift on the right side of the wing. This is the right side of the wing, and decrease the lift on the left side of the wing by changing the warp of the wing. And determining the lift is just like changing the incidence. It's a very similar process. So like, if this front is higher than the back side, it's gonna want to lift. If the back is higher than the front side, it's gonna want to go downwards. That's just how you analyze it. And yeah, so like in that case where I was talking about, like the diving case, so the plane's traveling nice and smoothly, and then it automatically just quickly dives. Yeah, you could change the how far forward and backwards the wings are. And if it was to dive, you might want to put the wings slightly forward, not all the way forward, just slightly forward, and then also change the warp. And then see how the plane reacts. And if it suddenly starts to stall, well, then you're gonna either want to put more clay in the front, or you're gonna want to move the wings backwards, or decrease the incidence. So there's a lot of things on this plane you can adjust to affect the flight's behavior. But each time you make an adjustment, and you'll learn over time, don't make an adjustment that's too extreme if the plane is working somewhat fine. And try not to change more than one variable at a time when you're starting off, because it just makes everything harder to understand. Just change one thing at a time. Understand how each piece works. Yeah. There's one last thing. Understanding flight behavior. So with the propeller, you can see that the propeller blades, so these plastic things are called the propeller blades, and they're angled. They're angled at a certain angle, like they're adjusted to a certain angle. And yeah, that affects how fast the propeller spins. So you can see it. Yeah, it just affects how fast the propeller spins. So if you have a really steep angle, the propeller is going to want to spin slower. If you have a really low angle, the propeller is going to want to rip through the air really fast. And most beginners shouldn't be changing this, but the reason you would want to change this is if the rubber runs out too quickly, you want to increase the angle of the blade so that the propeller moves slower. But you want to make sure the rubber is still powerful enough to lift the plane. So I'll just repeat that. Actually, let me go get some water. I'll be back. How do you teach it? How do you talk so much? How do you teach it? I'm hurting.
And then when you come home,
I just gotta finish this video. Alright, I'm back. Alright, so I think we're talking about propeller, I think. So I'll just repeat what I said before. If the plane is traveling too fast, you want to increase the angle of the propeller blade so that the propeller moves slower, so it cuts through the air slower. If the plane's not getting enough lift, so yeah, if the propeller's not moving fast enough for the plane to lift, well, you might want to decrease the angle of the blade so that it rips through the air faster. So what I mean by that is, if you think that all your adjustments are fine and the plane is still lowering, it's still falling slowly to the ground, well, that means you're not getting enough power from the propeller. So there are two things you could do. Decrease the decrease the angle of the propeller blade so that it spins faster, or you can increase the width of the rubber. So for example, this is really thin rubber, and to increase the power, you'd get a thicker rubber. This is a thicker rubber like this. So this piece of rubber right here is much thicker, so it'll be more powerful than this thin piece of rubber. Yeah, but as a beginner, you really shouldn't be changing the angle of the blades, because it just complicates too many things. Just focus on changing the rubber. You'll get fine times. What else? And yeah, if the plane is running out of lines really soon, and you feel like you found the right size rubber, like you think it's fine, well, then you want to increase the angle of the propeller blade so that the propeller moves slower. But you don't want to increase it so much that the propeller starts falling. So you're gonna want to trial and test the angle of the propeller blade so that you get a good flight. And I forgot to change the angle of the propeller blade. You twist these plastic pieces right here. You twist them So if you want to change this angle, you hold it like this, you hold it like this, you hold the center, you twist, twist. And then to do the same on the other side, you twist. And there's, I can't remember the device is, but there's a device that ensures that the angles that you twist it to are the same. I can't remember what it's called, but the Mr. Seuss or whoever the tech coach is at the time should know it, should have it in like one of the right stuff boxes. If they don't, you can find it on Freedom Flight, Dave Ziegler's Freedom Flight kits. That's not the website's name, but Dave Ziegler makes like Freedom Flight kits. Like this is a Freedom Flight plane. So on his website, he also has these like protractor like things. So you could make sure you're changing the angle correctly. Not correctly, but the same on each side. I think I talked about rubber. I guess I'll talk about rubber a little bit more. So, okay. We'll talk about rubber length, not thickness. We already talked about thickness. So, if you want the plane to move faster, higher, make the rubber thicker. If you want it to move slower and longer, and for it to unwind longer, you want the rubber to be thinner. So rubber length is also crucial. So this is the rubber length right now. For whatever your plane is, you're gonna want to wind the rubber to like a good amount. Wind it to like you feel like it's almost gonna break, and this takes practice. So you're gonna want to wind this rubber a lot until when you're winding rubber, you want to stretch it. So you're gonna put on the torque meter. Actually, I'll just make a different video for this. This was a video on understanding different aspects of the plane, like understanding the behavior of the plane, and I'll make another video on winding rubber.